This is Unit 12 Review, page 2. So the first thing here, when I look on the left and the right, I recognize there is a cosine on both sides. Now we are allowed to multiply either side of the equation or divide either side of the equation as long as it's done by the exact same amount, then it does not disrupt this original mathematical statement. So I'm going to divide both sides by. On the left-hand side, the cosines, remember they're not going to disappear, but they are going to be simplified to 1, and cosine of x divided by cosine of x is all. Let's move the 2 over, divide. And now remember, sine is like a y value, so I'm looking in quadrants 1 and quadrants 2 because the sine value is positive. Where is the sine equal to positive 1/2? It would be at 1 pi over 6 and at 5 pi over 6. Correct answer to problem 16 is A. Let's look at number 17. So when I look at 17 right away, I see something squared, such as cosine squared, and then there's a cosine, and then there's a value. I think this is probably going to be a. I'm not exactly sure how Mr. McFarland teaches this, but I'm going to let u equal the cosine of x. Let's rewrite this mathematical statement, replacing. All right, next I have 2u squared plus 1u minus 1 equals 0. Is this? What two numbers multiply to equal -2 and combine? 2 and 1 multiplied to equal +2. I need a -2, and I also need these two numbers to add up to +1. Now they multiply to -2, and they combine to a +1. So I make my factors here, u plus 2 and u minus 1. Don't forget, when the leading coefficient is anything other than +2, we need to bring it down and divide both sides in this case. Let's go back and replace u. What does u equal? U equals the cosine. This is looking like one of the problems we did in 1 through 6 from page number 1. I have two factors that is set equal to 1. If this is a true statement, either one of these factors equals 0 or they both equal 0. So let's set each factor equal to 0. And I've done that off the side. The first step will be to subtract 1 and 2. Now let's ask ourselves, where is the cosine on the unit circle equal to -1? Cosine is like the x value, and it's equal at 1. And where is the cosine equal to a +1/2? Again, cosine is like an x value. When it's positive, I know that it will be in quadrants 1 or 2. So +1/2 occurs at pi over 3, and +1/2 occurs at. Let's select the correct multiple choice answer. The correct answer for 17 was C. Let's look at number 18. Few things that I notice. I notice I'll have a plus or minus when I'm solving here because of the square, and I also notice I'm going to have to do 3 rotations or 3 cycles when selecting. It's not a difficult problem, but it is a long and drawn out problem. So let's figure out how to isolate this portion. I'm going to first add 4 and then divide by 3. Now to eliminate the square, remember this is going to produce a plus or minus, I'm going to square root. I know the square root of 4 is 2, and the square root of 3 is irrational. Next, notice that this is a cosecant. So the reciprocal cannot start with a c. The reciprocal is sine. I did notice that I forgot to put the plus or minus, even though I mentioned I forgot to take the plus or minus when I took the square root of the right and left hand side. So I put that back into place. Again, taking the reciprocal means I'm going to take this and flip it. So the square root of 3 comes up top and 2 is on the bottom. Let's look where we can locate in the first cycle, where do we have sine values that are radical, positive radical 3 over 2 and negative radical 3 over 2. Okay, sine is the second number, so this is the second number, which means it's a 60-degree reference angle. So at 1 pi over 3, 1 pi over 3, at 2 pi over 3, at 4 pi over 3, and at 5 pi over 3. Remember, the plus or minus because of the square allows us to choose the positives and the negatives. That's the first cycle. So in the first cycle, there are 4 different places around the circle where we have a positive or negative radical 3 over 2. So I set 3x equal to this quantity. And now when you divide by 3 on both sides, it's really like taking the bottom or the denominator. So to isolate the x, I take it times 3. To isolate the x, I take it times 3. And lastly again, times 3 and times 3. That's my first cycle. How many cycles do I need to do? 3 cycles. Now, is there a shortcut to doing this? That's what we're going to talk about. When I previously talked about a shortcut with you, we were talking about a reference angles of 30. Well, now we're talking about reference angles of 60. So let me darken. And we can see that there are 6 sectors. They look like equal pizza slices. There are 6 sectors in one revolution. And I'm going to show you how this allows you, when you have a reference angle of 60, also known as pi over 3, to do cycles in a quicker manner. So we need to go around this 3 times. So we've gone around the first time and we've selected 1 over 3, 2 over 3, 3, 3, 4 over 3, 5 over 3, and not 6 over 3. Now, why did I select these 4? Because each one had the specific sign that I was looking for. Now we need to do the second cycle. So I've done 1 over 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3. Okay, here's the next one. 7 over 3 I need to select. 8 over 6. Okay, we got 2 more to do. So I did 1 time around 6. There's 7, 8, 10, and 11. Why these? Because again, they have the exact same signs that I'm looking for. So I went second cycle, I already did 6, 7, 8, 10, 11. You can see that right here. So this is the second cycle. Now, is there a quicker way? There sure is. Watch this. Notice that there are 6 equal sectors when our reference angle is 60. So I go up to the first cycle, and when I have to do an additional cycle, I just literally add 6 to the numerator. 1 plus 6 is 7. 2 plus 6 is 8. 4 plus 6 is 10. And 5 plus 6 is 11. All right, let's go ahead now, and when we solve for x, remember we're taking the 7 pi, and now it's over 9, because when you divide by 3, you're really multiplying the denominator. I finished this out by doing cycle number 2 and isolating the x. So times 3, and times 3. Now let's use the shortcut to finish cycle. You may be thinking, well, why is she doing 3 cycles? Or how does she know when to start? When to stop? This tells you how many cycles. So if you don't see a number in front, you're only going down around once. This means to be 3 cycles. So I know that I'm just going to add 6. So I ended the first one at 7. I add 6 to end up with 13 pi over 3. Add 6 to get 14 pi over 3. Add 6, 16 pi over 3. Add 6 is 17 pi over 3. And then we're going to go ahead and we're going to isolate the x to get x. Here we have them. Each one of these, after I have isolated the x, would be our answers. So for this problem, we have 4 answers here for the first cycle, 4 answers for the second cycle, and 4 answers